I'm Matt Ahrens. I co-founded the ZFS project back at Sun in 2001, and we're here to talk about OpenZFS.
I'm George Wilson. I've also been involved with ZFS for quite a long time. Was not on the original team, but joined shortly thereafter.
So first we had some questions for you guys, which may result in you receiving a free t-shirt. So first of all, is there anyone here who has actually worked with the ZFS code, done any software development? Wow, quite a few people. You guys are our heroes, and you're all getting free t-shirts.
Sizes.
Yeah, what size would you like? Tell us what size.
Large, medium.
Large, medium, medium.
How many larges?
I think 2 larges, 2 mediums.
I'm sure.
Oh, sorry,
Those are smalls. We had all sizes small through double XL. So, who wanted larges?
Large.
We're going to see my t-shirt throwing skills. Almost.
I can help you.
Okay, here's another large.
Smalls?
Smalls? Anybody?
Or medium, sorry.
Mediums. You wanted a medium? Anyone else medium? Did I miss anyone? Oh, yeah. Okay, cool. So OpenZFS is all about the development community and improving the quality of ZFS on all different distributions. So you guys who have done work with ZFS code are, we inherently co-opt you into our community, but we also hope that you'll proactively participate, and we'll be talking more about how to do that. Next, we had some questions for people who have extensive experience using ZFS. So who here has the largest ZFS storage pool? Single storage pool.
You mean the room?
That you actually, not that your customers run,
Yeah.
but that you guys actually...
You actually use.
I'm a customer and I have 120 terabytes.
120 terabytes. Anybody can do better than that.
We've got bigger in the lab. One pool is 120. Yeah.
What's that?
So still 120 terabytes?
Well, in total it's 1.1 petabytes.
Oh. So not a single pool?
Yeah, one pool, single pool.
Single pool.
Yeah.
Ever or now?
160 terabytes.
160 terabytes.
Ever or now?
Oh, you win.
Now. Using in production, not like, I put it in a lab and
960.
900 terabytes.
Yeah, 900 in production.
Wow. I think he gets a t-shirt, yeah.
What size?
Who has the most number of snapshots in one storage pool? Like 1,000?
They said they told me to take ones away because I had over 3,000.
Over 3,000.
84,000.
84,000.
He wins.
Yeah, you win. 84,000. What size, what t-shirt would you like?
Call that one. Call a question on it's unusable. That's like a demo project.
Was that used in production? Or just you?
Semi-production.
Okay. Who has the most that they're willing to say they actually used in production?
We were using 3,000
All right.
production, then we got yelled at.
With our customer, we definitely have at least 50,000 right now in production.
Wow.
180,000.
180,000. Wow.
Cantrell told me I was an idiot.
Just for that, you get a t-shirt.
What size?
Large.
We only cut ours down to 1,000.
What other questions? How about widest RAID Z stripe? Who has the most disks in one RAID Z
It's
stripe?
not here, but we had a few interesting customers.
Production. Production. Anybody have more than 10?
I accidentally.
More than
Yeah.
10 discs?
Yeah. 26 wide.
Discs.
Wow.
More than 26?
I've seen
48.
Please tell me that was not rated 1.
RAID 10, man. You gotta be RAID 10.
Yeah. All right. What size t-shirt would you like? Yeah.
XXL.
Cool. And how about the most number of mirrors? So like the most number of disks in a mirror. So we've all done like 2-way mirrors. Somebody's probably done a 3-way mirror.
6-way or?
Yeah, this is in production, not just like, fooling around. Anybody with a 4-way mirror?
We have one customer
We have a
that does
customer.
do 4-way, but also he's making a backup. Yeah.
How many? 3-way. You guys have 3-ways. All right. What size? Do you already have a t-shirt?
Medium.
Medium. What question should we ask next?
Like you still have
Largest, who's got the largest arc?
Oh yeah, most memory that they're using.
Who's got over half a terabyte?
I have 144 gigabytes.
So more than half a terabyte?
Yeah, let's see if.
Anybody with more than half a terabyte on arc?
Single box?
Yeah.
Single box.
Single box, yeah.
512.
No, yeah, 144. Too small.
One,
He says 512.
512?
Yeah, that's probably.
He already has a T-shirt too.
Who's just under 512?
Come on, Luigi, you can meet that.
Nope, not in production. Not in production.
196.
196 gig.
Oh, somebody's got more than
56
196.
in production.
All right, you already
You got a
have
T-shirt. So
We'll go to you for 190. Is that what you said?
196 size?
L, please.
Okay. How about who has the most number of log devices that they're striping across in one pool?
Oh, that's a dangerous one.
I mean, I know a lot of people are using like one log device. Anybody like, there's probably people with a mirror. Anybody need more than just a mirror?
Oh, like 6.
How many?
Dual mirror.
2 mirrors.
Mirrors, stripes.
We have a customer with 8.
8 mirrors. Your customer, not you.
No.
Anyone else? All right. Nobody doing anything crazy there.
Yeah.
What about, I got one.
Yeah.
So our video system it's a terrible video system, but it breaks.
Is this advertising for your video?
Yeah, don't use our video system, but it puts all the files for all the cameras in one directory.
Oh, yeah.
It breaks the files every hour. I have 400,000 files in one directory, which it can't even like LS
Yeah.
or anything.
Well, that doesn't work partly because LS is so broken. I did tests on this 8 years ago to see how many files you could get, and ZFS was like, yeah, 1 million files, no problem. But then you type LS, and LS is like, yeah, I'll need about a terabyte of RAM to do that.
It's much more than a million, though, right? It's some.
Oh yeah, the actual limit is much higher.
Hours.
We stopped counting, trying to find over 400.
Does anyone
No idea.
does anyone have more than 400,000 files in a directory? And huge files too, I'm sure, if they're video.
Yes.
All right, T-shirt for you.
Find the medium.
What size? All right.
Think of one that I could actually win at.
Largest single largest file.
Yeah, who has a single largest file?
And then 2 terabyte VM. That's a single file from ZFS.
Oh, yeah. Anybody more than that?
2 terabytes?
All right.
1.5 terabytes?
Now you're out of a T-shirt.
What did you say, Z-balls or files?
Files.
Yeah, files more.
Files more interesting. Nobody has some giant VMDKs?
Well, now with 5.5, you can go up to 64 terabytes in a VBK, but
Yeah.
I'm on 5.1.
All right. Cool. So should we get started?
Yeah.
Just wait, soon people will have.
So what we wanted to kind of do first was talk a little bit about the history of ZFS, just to kind of scope the rest of the talk. So as Matt mentioned earlier, he was the co-founder of ZFS. The ZFS project actually started in 2001. Matt and Jeff Bonwick, one of our other colleagues, were the 2 engineers that were responsible for kind of getting this out of the ground. In 2005 was when the ZFS product was first open sourced. It was integrated October 31st of 2005 and made available via OpenSolaris at the time. I actually joined the project team in 2005, and one of my first tasks was to actually take that and put it into a Solaris production release. So I was the tech lead for the Solaris 10 update release and backporting the entire ZFS into Solaris 10 Update 2, which released in 2006. Shortly thereafter, in 2008, ZFS became available on FreeBSD. It's been around for quite some time. It's actually a quite stable release. And they also are pretty diligent about actually staying in sync with what is happening in the Illumos community. And then in 2010 was kind of the big event that people didn't really know what was going to happen shortly thereafter, and that was when Oracle decided they bought Sun Microsystems, acquired them, and then shortly thereafter they actually closed the doors on all open source contributions. And it was also kind of interesting because even though during the days of Sun and open source ZFS, there was never really a lot of development that was actually happening outside of the doors of Sun. yes, the code was available to the community, but the reality was most of that code actually came in through Sun. We had a few contributors, but for very small projects, but the majority of the development was actually happening in, behind closed doors. So even though Oracle closed the doors, the development process almost had always been somewhat closed. Well, at that time, a lot of people were concerned about what was actually going to happen to the ZFS community, both, at that time, OpenSolaris, what was going to happen to the FreeBSD version that was out there. Linux ZFS was kind of getting off the ground. Where were contributions going to come from? Where were people going to start doing development from? And that's when the Illumos project started coming to life. And that's the first time that we really see where a new project actually made it easier for true open source contributions to ZFS. The difference here between what we saw when ZFS was open sourced from Sun was that now we're actually getting contributions from all sorts of different organizations. You're seeing contributions from various players that are in this room, as we saw earlier with developers that have actually touched ZFS, as well as contributions that are coming from other platforms. And we'll talk a little bit more about that later. And then in 2013, the ZFS on Linux was actually made available, and this was kind of their stable release. And as just recently, we also announced the new community called OpenZFS, and this is what we really want to focus on today. So what is OpenZFS? It's actually a community that brings all the various platforms and all the other communities together. You can kind of think of it as an umbrella community for ZFS. It allows us to actually do things like collaborate on projects across the different platforms. So things that are happening in the Lumos community versus things that are happening in the FreeBSD community, all these things can be collaborative efforts now. As some of the things that are mentioned here, it's really geared towards raising the awareness of ZFS. Many people are aware that ZFS was a Sun product. Many people thought that it was only available, as an Oracle Solaris offering. What we're trying to do is make everybody aware that there's a much richer environment and a much broader development environment that's actually out there today. So this is primarily geared towards bringing developers together to raise awareness of ZFS, allow us to actually communicate on different things that are happening in each of the platforms, and also provide a very consistent view of what ZFS is going to be going forward. As a result, we have now this new website. This is where you can actually get most of the information about what's happening in the OpenZFS project. It's open-zfs.org. There is a platform independent mailing list. This is a developer mailing list where you can actually, if you're doing development out there and want to get involved, this is a great way to actually get involved in the process. We're also working on things to actually come up with kind of a unified code base that's going to make it easy for people to get contributions on other platforms. So today the development process has been, if somebody like, say Matt makes a feature change and actually goes into Illumos, somebody in the FreeBSD community has to go find that particular change and actually pull it in. And there's a lot of different things that happen because of the differences between FreeBSD and, say, Illumos that makes it difficult to take some of those change sets. For example, like if we use something like CV wait or task queues, that may not be available in another environment, another platform, which means that they may not necessarily be able to take that change set. We're looking now at trying to come up with a way to make ZFS, a core component of ZFS, applicable to all the different platforms. It'll make it easier for people to actually get features, whether they're contributed from a FreeBSD base or contributed from an Illumos base. It'll make it easier for people to pull those in much, much faster. The other thing that we're starting to do is we're starting to try to kind of let this development process and development culture kind of flourish. We're starting to hold open office hours. We've had our first one. We're getting ready to schedule our second one. So this is a great website to stay tuned. It gives us an opportunity to actually have developers such as myself and Matt. Other contributors from the different platforms will be available as well. So we're trying to make this a rotation basis, so you'll be able to get on and ask somebody, if you're a FreeBSD, developer and want to be involved in the FreeBSD version of ZFS, you'll see office hours for when we have the FreeBSD expert actually available and online. As I mentioned, this is kind of geared towards bringing all the different platforms together. So we now can see that we actually have ZFS available on Illumos, FreeBSD, Linux. There's an alpha version now on Mac OS. The various contributions that are going on there, but it's really geared towards raising this awareness that ZFS is much, much bigger than what it was originally when it was just under the head of Oracle. By the way, anybody running any version other than like Illumos or Solaris? What are you guys running?
OmniOS.
So OmniOS, so Illumos-based, FreeBSD,
Linux, I have one Linux.
Linux.
Linux 1.
Anybody running the Mac OS version, the alpha version?
Oh, yeah.
Oh,
Cool.
It just says, don't worry if things crash, so I think
yeah.
okay.
Along those same lines, there's also a rich development from various companies, because ZFS is becoming a storage platform not only for vendors who are selling storage, but also for people that are doing specialized appliances. Companies like Joyent, who are providing an environment, not necessarily selling you storage, but providing an environment for people to do compute on, or even somebody like Wheel Systems, which does a security-based appliance, but utilizes ZFS to store some of the critical data that's necessary for them to be able to do their accesses and monitoring that is provided by their appliance. So it's very broad in that sense. So what we're seeing is that ZFS is starting to flourish across all the various platforms, and we're starting to see a variety of companies. I mean, this is a small list compared to what really is out there. I'm sure there's several 100 companies that don't even want to be named yet that are probably utilizing or will be utilizing OpenZFS. That's the main reason we want to bring this development, bring it up to life, and make sure that it flourishes, because we know there's going to be a lot of people that are going to be depending on it. As a result of that, we know that this thing is going to grow. We know that there's going to be development that's happening across various platforms. We know there's going to be development that's happening across different companies. So one of the very first things that we needed to do for the OpenZFS version was to get this component that we call feature flags. So just a little bit of history. When ZFS was actually being developed inside Sun, every single time there was an on-disk format change, it was just an incremental bump in some number. So when the doors actually closed and the open source contribution stopped, we were at version 28. So many of you may have seen that version 28 was the only thing that was available out in the community. After that time, Oracle has since bumped that version, and I think they're up to 31, something like that. The problem with that is that works great when all the contributions are coming from a single company, because everything can be geared and driven through that one development process. That doesn't work when you're in the open source community. We want companies to be able to go and actually make changes and develop their on-disk format changes. And if Nexenta, for example, decides to make version 34 and Delphix decides to make version 34, when we actually come together and try to integrate, we're going to have a naming conflict. As a result, feature flags was born. The whole idea behind it is it allows each company to actually make their own individual contribution and make their changes to on-disk formats without having to interfere with anybody else. This is kind of the foundation feature that allows us to actually have these developers from various companies and from various platforms contributing additional functionality to OpenZFS.
So I'll just kind of reiterate that the idea of this is that features can be developed independently, but then later be integrated together into a common code base. So I want to talk about another feature that we've been working on in OpenZFS, which is to smooth out write latency. So this is a project that I implemented just recently. So in general, there's this problem where applications can send write requests down to the file system kind of at unlimited speed, as fast as the CPU can go. But the disk subsystem can only do writes at some much, much slower rate. So if the application is sending writes down quicker than the disk can absorb it, then at some point the file system has to make the application wait. So in traditional file systems, this might be accomplished by having, by basically doing the write to the disk in the application's context. So when the application says, please write this data, the data is immediately written down to the disk, and the application doesn't get to run again until that write to disk completes. But with ZFS, we're able to take in a bunch of changes from the application, buffer them, and then write them out to disk as a batch later on. The problem is that if we fill up all the amount of dirty data that we can have, then we can't take in any more application changes. So what can happen when you have a heavy write workload is that you fill up all the dirty data, and then we just have to wait. And all of the applications have to wait for all that dirty data to get flushed out to disk. So you see this very bursty kind of latency behavior. So here, this is a histogram of write operations showing that the vast majority of the operations completed very, very quickly in 1 microsecond. This is a log-log graph. So, but then at the very right here, you see this bump where there's hundreds of operations took more than 4 seconds. So those are the cases where basically all the threads of the application had to wait while we sync things out to disk. So the solution to this is to, as the amount of dirty data increases, we delay each write operation just a little bit. And then as there's more and more dirty data, we delay it a little bit more and a little bit more. So this will naturally find kind of a natural balance where there'll be a certain amount of dirty data and a certain amount of delay for each operation. So because of that, we get something that looks much more like a normal distribution where the vast majority of the operations all take about 1 millisecond, which is about the latency that the disk, in this case, could sustain. And we don't have any of these long outliers. So with old code, the outliers, meaning 99.99% of all the operations completed in less than 10 seconds. So we had, 1 in 10,000 operations took more than 10 seconds. But then with the new code, the outliers are only 30 milliseconds. So 99.99% of the operations completed in less than 30 milliseconds for a much smoother write latency and much more predictable behavior by the application, seen by the application. And I should mention that the goal here was not really to improve overall IOPS or throughput, but due to some kind of collateral fixage, we actually got a little bit better throughput here. So we went up from 56 to 5,900 IOPS in this particular workload.
Can we clap now?
Yes, you can clap now. And if you have questions, then also feel free to interrupt me. Cool. And we'll have some time for questions at the end too, I think. So another thing that's new in OpenZFS is LZ4 compression algorithm. So this is basically just strictly better than the previous default, which is LZJB. So it compresses things better, it decompresses almost twice as fast, and it gets a little bit better compression ratio than LZJB. So we found that for a lot of workloads, you can just turn on LZ4 compression and forget about it. Like everything goes better. You often usually get better performance with compression on because it reduces the amount of data that needs to be written to disk and read from disk. So now I want to talk a little bit about some of the stuff that's coming in OpenZFS. So as George mentioned, there's a lot of stuff that's coming down the pipeline that's being worked on by people at a bunch of different companies. So one of these is resumable send and receive. So a cool thing that is in OpenZFS is ZFS send progress reporting. So previously, in Solaris ZFS, for example, you could do a ZFS send. Maybe I should back up a little bit and just mention that ZFS send and receive is used to serialize a file system or ZVol and send it over the wire to another storage pool. So this is used in a lot of companies' remote replication solutions. So one of the problems that we had before OpenZFS was that there's no way to tell how big the send stream would be. So for an incremental send, it's hard to predict, like, well, okay, I know I changed some stuff, but how much has that collapsed? If I'm sending, from snapshot A to snapshot Z, how big is that stream going to be? So in OpenZFS, we added a way to calculate that, and a way to monitor the progress of the ZFS send operation. So you can see, oh, it's actually 95% down, I'll just wait for it to complete, as opposed to having to, start it, and then you think, oh, maybe it'll be done in an hour. And then later that night, you're like, well, it's still running, but hopefully it'll be done tomorrow morning. And you come in tomorrow morning, it's still running. I guess it'll be done soon. Don't worry about that. So in OpenZFS, we have progress reporting, but there's another problem, which is that, let's say, you waited all night long for the send to complete, and it's 85% done, through your like 10, your who had the biggest one, 2 terabyte file that you're sending, and then the network goes down, and the send stream, your TCP connection is broken. Well, in this case, you have to restart the whole ZFS send from the very beginning, losing all the progress that you've made. So we're working on a new feature in OpenZFS. Resumable send and receive, so that we're able to restart from a checkpoint of how much progress has been made already. So the solution is like the receiver is going to remember this bookmark that tells it I've gotten up to this object number and this offset in that object. Then that information can be relayed to the sending system, and it can resume from that place. So this is getting to some of the stuff that George mentioned, the development model. So the goal here is that we want to simplify the process of getting changes made to ZFS onto every platform that ZFS is on. So right now, this is done on kind of an ad hoc basis with kind of different policies for different platforms, FreeBSD versus Linux versus Illumos. So one of the ways that we want to address this is by creating this platform-independent code base. The idea would be that all the platforms would be able to pull verbatim from this platform-independent code base without having any differences to those files. And then the platform-independent changes would be pushed to this platform-independent repo first, and then pulled down. So the tricky thing here, or the critical part, is that we want to make sure that when changes are made to this platform-independent repo, that those changes are well tested, and we can be sure that we can test them on one platform, but be sure that they will actually work correctly on every platform. So the solution to that is to be able to run all the code that's in this platform-independent code base in a well-defined environment that would run in userland rather than in the kernel. And we would be able to test that code running in userland using the test suites that we have, ztest and test runner tests. So this wouldn't include platform-dependent code, like, for example, the ZPL, which is the POSIX layer, which interfaces with each platform's VFS, or virtual file system layer, because those VFS layers on different platforms are very different. So that code is not truly platform-independent right now, so it wouldn't be part of this code base. Cool. So there's a bunch more features that are being worked on besides the ones that I mentioned here, which you guys can ask questions about, because I think that we're doing pretty well on time. But I wanted to talk a little bit about how you can get involved in OpenZFS. So first of all, if you're making a product that's using ZFS, then let us know. We'd love to talk to you about what changes you guys are making, what changes you see needing to be made in ZFS, and get your use the OpenZFS logo, get your logo on the website and on the back of our cool T-shirts.
Yeah, if you don't see your logo on the T-shirt, let us know.
Yeah. If you're using OpenZFS as a end user or system administrator, help us spread the word about ZFS being available on all these different platforms. And there's also a bunch of opportunities for contributing to documentation on the OpenZFS wiki page. We have documentation both for end users as well as we're trying to build up some documentation for developers that are new to ZFS, trying to document some of the wide, what are all the different components, what do all these three-letter acronyms that are parts of ZFS do, how do they all interrelate? If you're writing code, join the developer mailing list. You can use it to get design help or feedback on your code changes. And if you're looking for things to work on, take a look at the project ideas page. Cool. So that's all the prepared content that we have, but we have time for several questions. And I will also leave this up in case you have questions about this. Yes.
So first suggestion is